welcome to this new lecture. We keep solving this MCQ by considering number 11. So let I included in R be an open interval and given two functions f and g, I from I to R, differentiable 3 times. So guys, keep in mind that here we have that the function is 3 times differentiable. Okay, so 3 times differentiable. This means that I don't know if it is 4 times differentiable, 5 times, but I know only for that is, I'm sure that it's 3 times differentiable on I. The indefinite integral of the third derivative of f of x multiplied by the second derivative of g of x is equal to, and then you have some proposals. Nice. First of all, you see that this a, I will directly say that a is false. Why a is false? A is false because I just know that the function is 3 times. The functions are 3 times differentiables. So I am not sure that the fourth derivative exists. If somebody tell me that something is just 3 times differentiable and he then use the fourth derivative, I don't know if it exists or not. Is that clear? So a is false because it used the fourth derivative, and I don't have the fourth derivative. But for the order, what should I do for the order? What I have to do, I have to find the integral of the third derivative of f multiplied. So I have to do the integral of f third of x multiplied by g second of x in dx. Nice. It's time to remind what we call the integration by part formula, right? That you saw at the high school and you also see it in class. So what the integration by part formula says, it's based on the so it means that if you have the integral of f prime times g, it will be f multiplied by g minus the integral of g. Now you see g prime times f. Look at the position of the prime. At the beginning the prime is on f, right? And at the end the prime is on g. This is the trick. So, or you can also see it like this: the integral of if you have g prime times f, it will be equal, by the way, we always have f times g, minus the integral of, now at the beginning, let's say that we'll have now f prime times g. So because at the beginning here you have the matter, if just all the game is about what was the position of the prime initially. Okay, now what do we want to do here? We want to solve the exercise asks us about the integral of the third derivative of x time the second derivative g. Now look, when you are working with the integration by part, you should choose one. You have two functions. You should choose one that is the derivative and another one that is the primitive. That is, we should choose one that you assume that it's a derivative and another one that you keep as it is. Yes or not? So you decide that one is f prime and the other is g, or you decide that one is g prime and the other is f. Now look, if I say that I will use, if I say that this, I will call this guy, okay, I will call it f prime and call this guy g. Okay, it means that I am trying to do what? This will means that I am trying to do the integral of f prime multiplied by g, right? That will be f times g minus the integral of what? G prime times f, right? Now, so we need to find f and we need to find g and the integral, yes or not? So what is my f? If f prime is the third derivative, f will be the second, right, of x. If g is the second derivative, what will be g prime? Yes, the g prime will be the third derivative of x. Now we are just applying, so this integral, by applying this formula, will be f times g. So f, which is will be the double derivative, times g, which is the double derivative again, yes or not, minus the integral of g prime, which means the third derivative, times f, which is the second derivative. So it will be second derivative times third derivative, yes or not? No, but we need g prime. We need, yes, it's the second derivative. G is the, look, g is the question of my student is that yes, is that clear? The question of my student was the following, that this one map with g prime, not with g, but in fact it doesn't map. This one, g second, is big G. Okay, so is that clear now? Okay. But this g prime, you use it here. But okay, let's go back to the PDF and see which one was the answer. Okay, so from the PDF you can understand that the answer was C, right? Because C. Okay. So we have second, third. That is second, third. Okay. So the answer is 11C. Nice. Let's move to 12. The primitive of the function f of x equal to this stuff on R is, so let me put it like this so that you, so the function is exponential of 2x multiplied by root of 1 plus exponential of 2x. Let me clean the board. So you have f of x equal to exponential of 2x root of 1 plus exponential of 2x. We want the primitive. We want a primitive, not the primitive. We want a primitive. What? So to find out the primitive, we have to do the primitive. All of the primitive are the integral of f of x in dx, right? This typically will be the integral of exponential of 2x multiplied by root of 1 plus exponential of 2x in dx. Nice. If you see it, we can write it like exponential of 2x multiplied by 1 plus exponential of 2x all to power half in dx. Which formula does it look like? The integral of what? It looks basically like the integral of f prime times f to power n, that we know it should be equal to f to power n plus 1 over n plus 1. This is the formula we know. Thus, going back, we see, but if you see here, what is the derivative of this? The derivative of, so let me write down the integral again. The integral, we wrote it like the integral of exponential of 2x times 1 plus exponential of 2x to power half in dx. This integral here, the derivative of this stuff here, only this stuff, its derivative is 2 exponential of 2x, right? So if to get what I need, I will write down the integral, which is exponential of 2x multiplied by 1 plus exponential of 2x in dx. Then I multiplied here by 2 and divide out by 2. Now you see that in fact all this is f prime and all this is f, but I lose my here is a 1 over 2. So nice. Here we have that the integral will give us finally 1/2, okay, because the integral of f prime times f is just this no, I mean, yes, this is f prime times f to power half, so it will be f to power 1/2 plus 1 all over 1/2 plus 1, right? So this will give us 1/2 multiplied by, what is my f? It's 1 plus exponential of 2x, so 1 plus exponential of 2x multiplied to the power 1/2 plus 1 divided by 1/2 plus 1. Now this is half multiplied by 1 plus exponential of 2x all to power 3/2 divided by 3/2. Now what means dividing something by 3/2? It means multiply by 2 over 3. So this is 1/2 multiplied by 2 over 3 time let's say that this stuff time 1 plus exponential of 2x all to power 3 over 2. Okay, so it just gives you 1 over 3, 1 plus exponential of 2x to the power 3 over 2. In fact, plus constant, right? Any constant. We forget the. Okay, by turning back to the when I turn back to the to all the stuff, you can see that for example, d is false. We don't have 2 over 3. We have 1 over 3, right? And then we try to they like to write it with this. So here we have 1 over 3. You see that 1 plus exponential of 2x multiplied by square root of 1 plus is actually 1 plus exponential of 2x to the power 3 over 2. This stuff is correct. Why? I mean, it means that E is correct. Why? Why E is correct? Because this stuff, I can write it like 1 over 3 multiplied by 1 exponential of 2x multiplied by 1 plus exponential of 2x to power half. This is to power when you multiply this and this, you get this. Doubts? So this will be then 1 plus exponential of 2x multiplied by square root of 1 plus exponential of 2x over 3 plus any constant, but in the exercise they choose the constant to be minus 8. Okay, because I repeat, from the primitive you can choose any constant. Doubts? This was 3 over 2. Okay, so the answer for this question is 12E. Okay, nice. Good. Is there any question? Okay. If okay, if there is not a question, we continue for 13 and 14 in the next video. Okay.